Section 4.6 Rational Functions. So we're going to talk about rational function, finding their domain, intercepts, vertical asymptotes, and horizontal asymptotes. First of all, any function, think about the rational number. If you think about rational number, the rational number is any number in this form a over b, where a and b are both real number. Similarly, a rational function means a function which is look like this: ratio of polynomial on the top and another polynomial on the bottom. Okay, that's called rational function. A rational function is a function of the form g of x over h of x, where g and h are polynomial function such that the function on the denominator, which is h of x, is not equal to 0, and the degree of this function is greater than 0. Okay, the degree of h of x is greater than 0. To find the domain of that rational function, we have to look at the denominator function. All real number except those for which the denominator is 0 will be in the domain of the function. For example, let's say f of x equal x squared minus 1 over x minus 2. As you can see that on the denominator, if I equate the denominator with 0, then I see that x equal to 2 makes this denominator 0. So the domain of this function is any real number except 2. Okay, and for finding the y-intercept, you just have to put x equal to 0 here and then find the value. For finding the x-intercept, it can be found by solving the equation g of x, which is the numerator function, equal to 0, provided that g of x and h of x do not share a common factor. So for finding the x-intercept, you need to factor out the polynomial on the top, you need to factor out the polynomial on the bottom, you have to cancel the common factor, and then the leftover thing from the numerator you equate with 0 and solve for x. That gives you the x-intercept. For example, for this particular function, the y-intercept is f0, which is 0 minus 1 over 0 minus 2, which is half. And for finding the x-intercept, you have to factor the top, which is x minus 1, x plus 1. You have to factor the bottom, which is already factor 8, which is x minus 2. And here you don't see any common factor, so you don't have to cancel it. So for finding the x-intercept, you just equate each of the factor on the top with 0 and solve for x. These are the x-intercept for this rational function. Now let's check. Let's say this is the function, and we need to find out the domain, y-intercept and x-intercept. For finding the domain, always equate the denominator part 0 and solve for x. Before that, I always find out the factors on the top and factors on the bottom. This is quadratic, so for finding the factor, look at the number here, 6. 3 times 2 is 6, so, and positive 1, so positive 3 and negative 2. These are the factors. Now for finding the domain, you equate this denominator, which is x plus 3 equals 0 and x minus 2 equals 0, solve for x. So the domain of this function is all real number except negative 3 and positive 2. So the domain is all real number except negative 3 and positive 2. So meaning, if you have to write down this thing using the interval notation, then you can say, okay, my domain is starting from negative infinity to negative 3, but I'm not including negative 3. Union sign from negative 3 to positive 2. Do not include negative 3 and positive 2, because at negative 3 and positive 2, this denominator would be 0. So you are dividing by 0, which is undefined. Union, the leftover thing is from 2 to infinity. So this is the interval notation for the domain of this function. You can also say the domain of the function is all real number except negative 3 and positive 2. How do you find the y-intercept? Just put x equal to 0 in the given function. So here 0 minus 4 over 0 plus 3 and 0 minus 2, which is negative 4 over 3 times negative 2, which is negative 6. And if you cancel the common factor, it would be 2 over 3. So this is the y-intercept. For finding the x-intercept, first of all, cancel the common factor from the top and bottom. You don't see the common factor, so no cancellation needed here. Now after that, take the numerator part and equate with 0 and solve for x. So this is your x-intercept. Okay, now vertical asymptote. Vertical asymptote means it's a line x equal to a is a vertical asymptote of a function y equal f of x if at least one of the following happens. This, look at the graph. When the function goes to that 0, either that function tends to infinity, negative infinity, from left side or from the right side. Okay, so when x approaches to a, that function is either positive infinity or negative infinity from the left side or right side. If it happens, then x equal to a is your vertical asymptote for that particular function. But the question is, how do you find the vertical asymptote? So to find the vertical asymptote of rational function, first of all, find the factors on the top, find the factors on the bottom, cancel the common factor, and then equate that denominator thing. After cancellation, whatever leftover you see on the denominator, equate that with 0 and solve for x. That will give you the vertical asymptote. For example, let's say f of x equal x minus 1, x plus 1, x minus 3, x plus 1. So let's say this is your rational function. For finding the vertical asymptote, first of all, you cancel the common factor. And now, whatever leftover you see on the denominator, which is x minus 3, you equate with 0 and solve for x. That is your vertical asymptote. Vertical asymptote. One example. Let's say this is the function x minus 3 over x squared plus x minus 6. First of all, before finding the vertical asymptote, you need to find the factors on the top and factors on the bottom. So you see, if there is any common factor, you cancel out. Otherwise, you take the denominator part, the factors from the denominator, and equate with 0 and solve for x. So these two, x equal to negative 3 and x equal to 2 lines, are vertical asymptote, meaning when x equal to negative 3, this is negative 3, and x equal to 2, the graph of this function will go to either a positive infinity or negative infinity from the left or right side. That's the meaning of a vertical asymptote. The graph never intersect these two lines. And for finding the horizontal asymptote, this time the same thing happens, but instead of vertical line, it's a horizontal line. A horizontal line y equal h is a horizontal asymptote of a function f if the values of f of x approach some fixed number h as x approaches to positive infinity or negative infinity. Meaning, when you go to the extreme right, which is x tends to infinity, or extreme left, when x tends to negative infinity, if this function approaches to some number h, that line y equal to x is called horizontal asymptote. How do you find the horizontal asymptote? There are three different cases you might have. The first one, so remember your function is a g of x over h of x. This is your rational function. So for finding the horizontal asymptote, you compare the degree of the polynomial on the top and the degree of the polynomial on the bottom. Although a rational function can have many vertical asymptotes, it can have at most one horizontal asymptote. So keep in mind, you cannot find more than one horizontal asymptote for the rational function. The graph of a rational function will never intersect a vertical asymptote, but may intersect the horizontal asymptote. That is one thing you have to keep in mind. A rational function that is written in lowest term, meaning you just cancel the common factor from the top and bottom, will have a horizontal asymptote whenever the degree of h of x is greater than or equal to the degree of g of x. So the degree of h of x the denominator should be greater or equal to the degree of g of x. If the degree of g of x is greater than h of x, then there will be no horizontal asymptote. So these are the three rules you have to keep in mind. Let's write down the polynomial on the top and the polynomial on the bottom as this. So as you can see that the polynomial on the top has a degree n, the polynomial on the bottom has a degree m. Okay, and then an and bm are non-zero number. So now you compare, to find the horizontal asymptote, you compare the degree on the top and the degree on the bottom. So if the degree on the bottom is greater than the degree on the top, then always y equal to 0 is your horizontal asymptote. If the degree on the top and bottom are same, then y equal the coefficient of the highest degree term on the top and then coefficient of highest degree term on the bottom. Y equal that value would be your horizontal asymptote. In case if the degree on the bottom is less than degree on the top, meaning the degree on the top is greater than the degree on the bottom, then there will be no horizontal asymptote. One example. So here you can see the degree on the top is 1 and degree on the bottom is 2. So the degree on the bottom is greater than degree on the top. So the degree on the bottom is greater than degree on the top. So y equal to 0 is your horizontal asymptote. Okay. The degree of the denominator is greater than the degree of the numerator. Therefore, the graph has a horizontal asymptote whose equation is y equal to 0. That's just you compare the degree on the top and bottom and you can find out this information. Another example, look at this function. The degree on the top is 2. The degree on the bottom is 2. So that means they have the same degree. So if you go back to that rule, if they have the same degree, the horizontal asymptote comes from the coefficient of highest degree term over the coefficient of highest degree term. So in this case, the coefficient of highest degree term on the top is 2. The coefficient of highest degree term on the bottom is 1. So y equal that value would be, which is y equal to 2, is your horizontal asymptote. Okay, the degree of the denominator is equal to the degree of the numerator. Therefore, the graph has a horizontal asymptote whose equation is y equal to 2. Final example. Compare the degree on the top, which is 3, and compare the degree on the bottom, which is 1. Since 3 is greater than 1, since the degree on the top is greater than 1, so there will be no horizontal asymptote. So the conclusion is the degree of the denominator is less than the degree of the numerator. Therefore, the graph has no horizontal asymptote. That is possible. Okay.